Okay, this is the the last permutation problem of the probability workshop. And let's just do it. 5 boys and 4 girls go to the movies. They're all seated next to each other in the same row. Ooh, okay. Sounds like 9 people. But now let's see. 1 boy and girl are a couple, and they just really want to sit next to each other. Not only that, they want to sit at the end of the row. So that's 2 people that are kind of taken out of the story. And in how many different ways can the entire group be seated? I really like drawing boxes. And so what I do is I draw one box for the boy and girl together, and I put them at the end, and that's one possibility. And then, let's just take a look at that. Let's take a look at how I put it together. And I've got them at the other end, a boy and girl, but there'll be like 7 people in the middle that have the whole kind of permutation arrangement thing going on. So you draw a picture like that. I really like using boxes. So here's a box for the girl and boy that are put together. And here's the 7 people in the middle. Well, the number of ways you can arrange 7 people is just 7 factorial. Okay. Well, then there's the people on the left, that's 2 factorial. And then there's the people on the right, that's 2 factorial. So there's 2, because they can sit on the left side or the right side. And that's why the answer in the memo is this number, 2 factorial times 7 factorial times 2 factorial, because you got 2 different ways they can get arranged on the left and the right, and there's 2 ways they can get you think how they can be seated, because you can have the boy girl or the girl boy. Anyway, it's just the product of those things. But the key thing is you've got the 7 people in the middle, that's 7 factorial. So that's the key part to it. And if you think about all the possible ways they can be on the end in each other, it's just 2 times 2, and that's all there is to it. It's not so hard. Now, if all the friends are seated randomly, calculate the probability that all the girls are seated next to each other. Let's look at how I did this. Well, what I did is the total number of ways that 9 people can be arranged is 9 factorial. So if we're figuring out boys and girls, if you've got 9 different people, there's 9 different boxes, and you would just go 9 factorial. But hey, how many different ways can 4 girls be arranged? Well, that's 4 factorial. How about the boys? Well, you've got 5 boys, but the girls kind of operate as one. If we create them, okay, and if the friends are seated, calculate the probability, all the girls are seated next to each other. So we have to kind of think of the girls as one thing, right? If the girls are going to be sitting next to each other, we treat them as one part there. And how many different ways can all those girls be arranged is 4 factorial. But we treat them as one, like we tied a rope around them. You've got the 5 boys plus that one group that's all tied together. That's 6 factorial. So the total possible ways that permutations for that is 4 factorial times 6 factorial. And it's all over 9 factorial. And I just put that in my calculator. You try it, and your calculator will simplify it and tell you it's 1 chance in 21, which is good enough for your answer there. Turns out to be, as a decimal, 4.76% chance of happening. So that's it. You got to, when you're doing probability, total number of things that can happen go in the bottom. So the total permutations in the bottom. And then you got to think, okay, 4 girls all sitting together. Well, there's 4 factorial ways that can happen, arranging all the girls like that. But then you treat the girls as if they're just sort of one possibility, with the 5 different boys all in between and around in different ways. That's 1, 2, 3, 4, 5, 6 different 6 factorial ways to arrange. And you multiply it together, and that's it. It takes a while to get used to this thing, but it's a little bit easier if you play with the boxes. Like I'd have 1, 2, 3, 4, 5 like this, and all the girls would be like, I'd think of them as one box there. Okay. There you go. Whoops, stop recording.